Hey, good morning. I'm just waiting for more grade 9 learners to join, and we'll start. Maybe let's give them 6 more minutes. We'll start at 10 past. Let's just wait for more people to join. Uh, Otherwise, hello. Let's say, oh, it's good seeing you. I can see you there. Yeah, let's just wait for them to join. So where you at now, Craig? You said you to us who did maths lit, we stopped by grade 9. What grade are you doing now, Mr. Craig? Okay, welcome to those who are joining in the session for grade 9. Please do tap on the screen so that we can get the live at least visible, so that it gets to the FYP page, and that hopefully we can get more people to actually also see that there's something happening here with grade 9. So for now we'll have grade 9 from 7, and then at 8:30 we'll have grade 10 come in. So to those who are admins for the respective WhatsApp groups, if you can actually share this schedule to the respective groups, then later on this evening for grade 8 at 7 p.m. and then we'll have grade 11 at 9 p.m. And those are the topics we'll be covering for today. Then remember that all the sessions that are done here are then uploaded onto the YouTube channel, so that if there's people who have missed the sessions, they can actually catch those content that they may have missed on the YouTube channel. Just like all the sessions that we did last week, they are already uploaded on the YouTube channel, so people can actually catch up if it is that they missed out on those sessions. That is for grade 9, for grade 10, for grade 11, and for grade 8. Please, those who may have come across this TikTok live for the first time, you're more than welcome to actually share the live with others. Also, if you have kids, if you have nieces, if you have nephews, they are going to be going to the following grades, the grades that you see below, and they need some push assistance, help with mathematics for these grades, then please do share the live session with those people and also share the page with them. This page will be very much helpful. It will be a lifeline for many learners here in South Africa that need assistance and help with mathematics. I'm not only just someone who tutors maths, but I'm someone who actually teaches maths in the school system for the CAPS oriented kids. So I do teach at an official school. I'm actually going to be teaching grade 12 and grade 9 next year, mathematics. And I have been teaching for the past 7-8 years. So I come with a bit of experience and also a bit of know-how, in certain aspects of the syllabus for the respective grades. So please, like I said, do share the live and do double tap on the screen so that we can claim visibility and also that it can be able to maneuver to the FYP page. And then also, just an encouragement, there may be people that are here that have thought, I would like to do something like this. Maybe you are good at maths, maybe you are a university student, you are done with mathematics, high school, but you were good. Doing something like this, having live sessions on your page, if you already someone who's able to do live sessions on TikTok, doing something like this may really help a lot of learners in the country. So please don't be scared to do something like this. If fear is the one that's holding you back, don't allow fear to hold you back anymore. Do it so that many learners can benefit. The minute you start sessions on your page that are mathematics oriented, or maybe any other subject, maybe you were good at life science, maybe you were good at geography, maybe you were good at, any other subject, go ahead, do live sessions. But for this page, it's simply a maths oriented page. I don't do any other sessions besides mathematics. So right now, I will now start with the grade 9 maths session, and today we'll be covering properties of whole numbers, and then we'll go into multiples and factors, and then that will take us through up until just 10 past 8. So welcome welcome to my regulars, those that actually do join consistently and that have been joining so far, and then to those who are joining in for the first time, also welcome to you too. Okay, let us get started. All right. Let me just wipe the lens. All right, let's go, guys. So today we'll be looking at, just before we jump into what we actually have scheduled for today, we are going to revise something that is usually done in grade 8 that has to do with properties of whole numbers. So this is for grade 9, like I said. Those who are in grade 9, who are going to grade 9 next year for maths, this is for you. So, and like I said, those who may be joining for the first time and are like, I have never had an opportunity to join these sessions before. We've been doing sessions for next year for the respective grades, grade 8, 9, 10, and 11. Please do go and subscribe to my YouTube channel. It's called Maths is a Game as well. You can go to my bio. There's the YouTube icon. You can click on it. It will send you to the YouTube page. And all the sessions that we've done in the previous weeks are already uploaded onto the YouTube channel. Okay, so today let's look at properties of whole numbers. This is something that you did in grade 8. Okay, so just stick with me and listen very carefully. If you have a notebook, please have a notebook ready. Write down the notes as needful, and also, tag along. It will be a beneficial next hour, an hour that will be worth your time. So properties of whole numbers, let's look at them. We have a few properties of whole numbers that we need to know. So the first thing that we need to know when it comes to properties of whole numbers, 1, when you add numbers. Okay, so when you add numbers or multiply numbers, you get the same answer, right? Whatever the order in which you place them. I'm going to repeat. When you add numbers or multiply numbers, you get the same answer, whatever the order in which you place them. Full stop. We call this the commutative, and this is an operative word, commutative property of addition and multiplication. So what is this saying? It's saying whatever order in which you place numbers when you are adding and subtracting, the answer you will get will be the same. This property is called the commutative property of addition and multiplication. Okay, so let's look at this. In other words, a plus b, meaning the addition of two variables, is equal to b plus a. So if you look at a, then you add b. It doesn't matter. You can start with b and add a. The answer will be the same. So if we look at an actual practical example, it's like saying 1 plus 2 is equal to 2 plus 1. What is 1 plus 2? The answer is 3. What is 2 plus 1? The answer is 3. So whatever the order is, when we are adding, the answer will be the same. This is what we call the commutative property of addition. It's grade 9, Jabulu. It's grade 9. Okay. But it's a revision of grade 8, this aspect. And let's look at this. What about multiplication? A times B is equal to B times A. Alright? In other words, 2 times 1 is equal to 1 times 2. What is 2 times 1? The answer is 2. What is 1 times 2? The answer is 2. So whatever the order in which you place numbers when you are multiplying, the answer will still be the same. We call this the commutative property of what? Of multiplication. Okay? So this is very important. Very, very important. So let's move right along. So the first property is called the commutative property of addition and multiplication. What does it basically have to do with? It has to do with the fact that however you place numbers when you are adding and subtracting, whatever the order, you will still get the same what? The same answer. This is what we call the commutative property of addition. As you saw in this example, a plus b is equal to b plus a. In other words, 1 plus 2 is equal to 2 plus 1. The same answer, all right? Or commutative property of multiplication. However you place the order of numbers when you multiply, you'll still get the same answer on the left and the right. Okay, so that's the first property. Let's move along. Let's go to the second property. Guys, this commutative property of addition and multiplication has to do with the order in which we place numbers when we are adding and subtracting. However you place the numbers, you'll still get the same answer. 1 plus 2 is equal to 2 plus 1. 3 plus 5 is equal to 5 plus 3. 9 plus 1 is equal to 1 plus 9. 2 plus 7 is equal to 7 plus 2. So however you place the order of those numbers, you get the same answer. With multiplication as well, however you place the order of the numbers, you will get the same answer. 2 times 1 is equal to 1 times 2. 3 times 5 is equal to 5 times 3. And so it goes. So it doesn't matter the order. We call this the commutative property of addition. And generally we say A plus B is equal to B plus A. And the commutative property of multiplication. A times B is equal to B times A, and so it goes. Let's go to the second property. The second property says, when you add or multiply, I repeat, when you add or multiply 3 or more rational numbers, you get the same sum, that is for addition, or product, that is for when you multiply, no matter how you group or associate the numbers. I'm going to repeat this. When you add or multiply 3 or more rational numbers, you get the same sum or product no matter how you group or associate the numbers. So let's look at what this means. A plus B, that's 2, in brackets, plus C, that's your third, is equal to A plus, look at the bracket this time round, B plus C. So however we group the numbers, we are still going to get the same answer. If we have addition right throughout, A plus B, we group the first two, plus C, is equal to A plus B plus C, we group the last two. All right. We associate the first two, we associate the last two. Whatever the order, what we associate, we still get the same answer. So let's read an example. 1 plus 2 plus 3, we group the first two for the first expression on the left. For the second expression on the right, 1 plus 2 plus 3, we group the last two. We should essentially, for addition, get the same answer. What's 1 plus 2, guys? It's 3. What's 3 plus this 3? It will give us 6. We had grouped the first two, we get 6. Then, let's look at this one. 1 plus, brackets, 2 plus 3. We associate the last two. 1 plus, what's 2 plus 3? It's 5. What's 1 plus 5? It also gives us 6. So whichever two we decide to group, for addition of 3 or more numbers, we are going to get the same sum, or let's look at the product now. A times B times C, we group the first two or associate the first two, is equal to A times B times C, we group or associate the last two. We should, in essence, for products of 3 or more numbers, still get the same answer. Okay. I don't know why this phone usually does this. You see, it's blurry. I'm sure you guys can see the blurriness. I hate how it does that. I don't know why it does that a lot. In focus, out of focus, it just gets blurry sometimes. It frustrates me when it does that. Frustrates me all the time. Okay, anyways, let's look at this. We associate 1 times 2 times 3 alone is equal to 1 times, we associate the last two, 2 times 3. So in essence, the answer should be the same for the product of 3 or more numbers. Look at this. What's 1 times 2? It's 2. What's 2 times 3? We get 6 on the left. we associate the last two instead of associating the first two. What do we get still? 1 times, what's 2 times 3? It's 6. What's 1 times 6? We get 6 on the right side as well. So the answer will still be the same if we associate the first two for multiplication or the last two for multiplication for the same 3 numbers. If it's addition, if we associate the first two, associate the last two, we still get the same answer for addition as well. What do we call this? We call this the associative property. The associative property. Okay, that's what we call it. The associative property. Okay. And it's for what? It's for addition and the associative property for multiplication. All right. Let's go. Next property. The distributive property. Distribute. Okay. So the word distribute means to sort of like send out. Okay. You can imagine, for instance, Santa Claus. I don't know. Santa Claus will be distributing presents to various homes, for instance, come the 24th. Right? We all believe in Santa, right? Okay, so distributive property of multiplication over addition and subtraction. So we're going to look at the distributive property. Okay, distributive property, if we look at it closely, like I said, it's the distributive property of multiplication. All right, so the distributive property only applies to multiplication, but it's over two things. Firstly, it's over addition. Let's look at over addition. So A into B plus C. So A into B plus C. Now these brackets here with the A here, A into B plus C. These brackets, the A next to the brackets with no sign between the A and the B. The brackets here mean multiplication. That's what the brackets mean. When there's a letter and there's no other operation, okay, between A and the bracket, then it means A and the bracket mean multiplication. Then we have B plus C inside the bracket. All right, so this simply is equal to, we take the A, it gets distributed to the B by multiplication. So you'll get A times B. Then you take the A, you distribute it to the C. The brackets mean multiply. Then we'll get plus A times C. This is what we call distributive law. Distributive property. We are taking the A, multiplying it with the B. We get A times B. We are taking the A, we are multiplying it with the C, but it's over addition. So it's going to be plus brackets A times C. Hopefully that makes sense. So this is what we call the distributive property of multiplication, but over which sign? Over addition. So let's look at an example. We have 1 outside, brackets 2 plus 3. So when we apply the distributive property, we say 1 times 2. So we take the 1, we distribute it to the 2 using multiplication. That's why we have 1 times 2 in brackets. Then we take the 1, we distribute it to the 3 over what? Over addition. So we say plus 1 times 3. That is the distributive property of multiplication. We are multiplying over what? Over addition. Okay? Let's look at now the distributive property of multiplication over subtraction. Let's look at this. Look at this example. A into B minus C. What do the brackets mean? The brackets mean multiply. So we take the A, we distribute it to the B, which gives us A times B. We take the A, we distribute it to the negative C. So in other words, we are distributing A over subtraction, which will give us minus, for the minus sign that was there. A was positive, times the C. And remember, the C was negative, but we put the negative here to accommodate the negative sign in between B and C. Hence, we call this the distributive property over a subtraction. Okay, the distributive property of multiplication over subtraction. So if we look at an example, 1, we're going to distribute to 2, so we're going to get 1 times 2. Then we take the 1, we distribute it to the negative 3, we get minus 1 times 3. This is the distributive property of multiplication over subtraction. 1 times 2 in brackets, minus 1 times 3. Okay, so basically, in essence, this is what we call the distributive property. Okay, hopefully that makes perfect sense. Right, so these are the properties that we need to be very much aware of. Okay, so just a quick game challenge here that I want us to check firstly so that we can identify the properties. All right. I want you guys to tell me whether this statement is true or false and what property it is. 4 times 6 plus 9 is equal to 4 times 6 plus 4 times 9. 4 times 6 plus 9 is equal to 4 times 6 plus 4 times 9. Is this true or false? And if it is true, what property are we applying for this mathematical statement? Okay, so Ria says it's true. Okay, the second question, what property has been applied for this? Princess says true, very good. Ria, thank you so much. What does everybody else say? What property has been applied here? Very good, Lesejo. All right. Okay, so yes, guys, 4 times bracket 6 plus 9 is equal to 4 times 6 plus 4 times 9. Is this statement true or false? Yes, it is true. What property has been applied? We have applied the distributive property. Let's remember, which distributive property? It's the distributive property of multiplication over which sign? Over addition. Okay, so we would say true. What has been applied? Distributive property. So we're not just going to leave it at just distributive property. We're going to say the distributive property of multiplication over addition. Okay. Because yes, it would have just been easy to say distributive property of multiplication. But we know it's over which sign? It's over addition. 4 gets distributed to 6. We get 4 times 6 in brackets. 4 gets distributed to 9. Over which sign? Over addition. We get plus 4 times 9. So this is the distributive property of multiplication over addition. Okay, let's look at another example. I want you to tell me if this is true. 4 plus 6 plus 9 is equal to 4 plus 6 plus 9. True or false? True or false, and which property has been applied? 4 plus brackets 6 plus 9 is equal to 4 plus 6 plus 9. Okay, so I can see people are saying true. That's true. What property has been applied? I agree with you, it is true. What property has been applied? Okay, all right. So let's see. Ria says associative. Lesejo says associative. Do we all agree, guys? Is it the associative property? Princess says the associative. Okay, all right. So yes, guys, it is the associative property. The associative property. And this associative property, it's for what? Of addition. Okay. 3 numbers added together. Group the last 2, group the first 2 on the right side. This basically is true, all right, for addition, remember? So it's the associative property of addition. Thank you so much, Letabo. This is for grade 9. Okay, this is for grade 9. Let's look at another statement. 3. I think we are going good. So far, so good, guys. So far, so good. Okay, here's another statement. First and foremost, want to establish if it's true, and then we'll proceed from there. Chris question. 4 times 6 minus 9 is equal to 4 times 6 plus 4 times negative 9. Is this statement true or false? Let's start there. Let's wait for the property. Don't speak about the property yet. Just want to check, is the statement true or false? Okay, I'm going to look at the comments here. Ria says false. Lesejo says false. Letabo says false. Princess says false. Tasha says the same thing. Okay, let us check by working this out and actually check if is it true or not. Okay, so guys, we could have done the same thing here, all right? We could have done the same thing here. If we look at the right, for instance, what's 6 plus 9? 6 plus 9 is what? It's 15. What's 15 times 4? It is 60. So the answer we get on the right is 60. Let's look at the side. What's 4 times 6? It's 24. Plus, what's 4 times 9? It's 36. What's 24 plus 36? It is 60. Hence, we say this here is true, the original, the first statement. Okay? We know the property, we can see it. Let's look at this one. Remember this one, we said it's also true. What's 6 plus 9? Because remember, Bodmer says start with brackets. What's 6 plus 9? It's 15. And then what's 15 plus 4? It's 19. So we have 19 on the left. Let's look at this side. What's 4 plus 6? It's 10. What's 10 plus 9? It's 19. So that's why we say this statement is actually true. All right, and then we wrote the property. Let's come here now. I am asking, is this statement true? That's the first thing I've asked. Is the statement true? 4 times bracket 6 minus 9 is equal to 4 times 6 plus 4 times negative 9. Is this statement true? And most of you have said the statement is false. So let's look at it. What's 6 minus 9? 6 minus 9 is negative 3? What's 4 times negative 3? Okay, so a positive times a negative gives me a negative. And then what's 4 times 3? It's 12. So the answer is negative 12. Let's look at this side, guys. What's 4 times 6? It's 24. Plus, what's 4 times negative 9? Positive times a negative gives us a negative. What's 4 times 9? It's 36. So we have negative 36 in brackets. Then let's move on. What's 24? Positive times a negative gives me a negative. So I have negative 36. What's 24 minus 36? It's negative 12. So what do you guys see? I get negative 12 on the left. I get negative 12 on the right. So my question again, is this statement true? Drip Lord, you can see the statement is actually what? True. How did we establish that the statement is true? We looked at the left side, we worked it out. We looked at the right side and we worked it out. And what do we get? We get the same answer, right? So let's look at this very carefully. What happened here? Okay. 4 got distributed to 6. That's what happened. 4 got distributed to 6. 4 times 6 is equal to 4 times 6. Then 4 got distributed to negative 9. But they were very clever in how they did it. They put a plus sign here, and then in brackets they said 4 times the negative 9, which is perfect. All right? Perfect. Okay, so they slightly applied the distribution of 4 into this bracket over subtraction by making sure that they put a plus sign but accommodate the negative sign inside the bracket, which is no different from actually doing this. 4 times 6 minus 4 times 9. Because at the end of the day, what's going to happen? The number here, this number at the end of the day will be negative. Just like here. After you've multiplied the 4 and the 9, you'll get a 36, but the 36 will be negative. As well as here, 4 times negative 9 will still leave you with a negative number. I hope you guys can see this. So this is just a clever way of actually still using the distributive property over subtraction by actually making sure that you take the sign inside the bracket and then you leave a positive sign in between to separate the two brackets. All in all, guys, all in all, you actually do get the answer. So basically, like I said, this statement is equal to this statement. Therefore, if it's true, what type of property was used? The distributive property of multiplication. It's still over addition, but just with a bit of a twist. Okay, right. So let's make sure we check our statements before we conclude. All right. It's funny, these comments that people are punching in. Litla bona dipuka ka January birimarung. Hey, funny, you guys. People are joining in that are funny here. Okay, guys. I hope that statement, we are very clear, right? Are we together, those people that have been here since the beginning, those who are actually here for the maths and not here to distract us? Can I proceed? Okay, thank you, Ria. All right, let's move on. Let's look at another one. 4 plus 6 minus 9 is equal to 6 minus 9 plus 4. 4 plus 6 minus 9 is equal to 6 minus 9 plus 4. First statement, is this true? 4 plus 6 minus 9 is equal to 6 minus 9 plus 4. Tando P, I suggest that you go onto my TikTok page. The most recent video that I posted has the schedule for my math sessions for today. I'm doing grade 9 at the moment, and the other grades, just check it out on my maths page. Okay. Is this statement true? 4 plus 6 minus 9 is the same thing as 6 minus 9 plus 4. Ria says it's true. Lesejo says it's true. Okay. I just need more people to answer. Okay, so let's look at this, guys. Let's look at this. Okay, MZT says it's true as well. Okay, so let's look at this. What's 4 plus 6? 4 plus 6 is 10. What's 10 minus 9? 10 minus 9 gives us 1. So on the left, we have 1. Let's look at the right side. What's 6 minus 9? Okay, if you guys don't know addition and subtraction of integers, then I'd suggest you take a calculator and utilize it, okay? 6 minus 9 is negative 3. What's negative 3 plus 4? That gives us negative 3 plus 4 is 1. So we have 1 on the left, we have 1 on the right. So is this statement actually true? Yes. Let's look at the composition of the numbers. 4 is positive on the left. 4 is also positive on the left. 6 is positive on the left. 6 is also positive on the right. 9 is negative on the right, and 9 is negative here as well. So is this statement true? Definitely, guys. It is very much true because the numbers are the same on the left and the right. We're not going to go into property because obviously, basically here, yeah. I think you guys can see though what basically has been done here. It's like, for instance, this 6 minus 9. Do you see what they did here? It's like there's some sort of association that has happened here. 6 minus 9 is written first, 6 minus 9 is written last. The 4 is written first, the 4 is written last. So there's kind of like a mix of both the associative property. They didn't put brackets here, but you can see basically 6 minus 9 is last, whereas here 6 minus 9 is first. So it's like they've used the commutative property in a sense. Because 6 minus 9 grouped first, 6 minus 9, group last, 6 minus 9 grouped first, but between the 4 and the 6 minus 9 relationship, there's an addition. So we have the commutative property of addition that has actually been applied just a bit more extensively. Okay, yes, we can, Ria. Commutative property, you can see, because 4 plus 6 minus 9, look at the 6 minus 9, 6 minus 9 plus 4, right? Remember, there were no brackets initially, all right? So with them just loosely written, 4 plus 6 minus 9 is equal to 6 minus 9 plus 4. We can definitely say commutative property, okay, let's move on. Okay, and we can say it loosely, we don't have to say of addition, but yeah, we can say that. Let's move on to another one, just one last one. Sorry. First question, true or false? Lesejo, you were very fast to answer. Lesejo was very fast to answer. Very, very fast. Okay, Lesejo says false. Ria says false. Uamo says true. Luleko says true. Momedi says true. Okay, let's look at this, guys. If you're saying true, let's look at this. What's 2 minus 7? And I really encourage you guys that if you are really struggling with addition and subtraction of integers, take your calculator. It will never fail you. Right, so I have mine in front of me. I'm going to say 2 minus 7. Look at this. Your calculator is amazing. It gives me the answer. So on the left, I have negative 5. Let's look at the right side. 7 minus 2. 7 minus 2. I get 5. That's positive. So I have a negative 5 and a positive 5. Guys, are these two equal? Can you say negative 5 is equal to positive 5? So is this true? No ways. So I write this line to show that negative 5 is not equal to 5. So this statement is what? It's false. All right? Yeah. The commutative property only applies to addition and multiplication only. Does it apply to subtraction? If I change the order of the numbers and there's minus sign, does it apply to subtraction? No. Commutative property only applies to addition and multiplication. Okay? So, hopefully you guys understand this. Let's look at one last thing. 4 divided by 1 is equal to 1 divided by 4. True or false? Let's say for false, princess false, 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 false. I hope you guys can see that. Okay, if we change the order of the numbers for division, do we get the same answer? Definitely not, guys. Definitely not. 4 divided by 1 is 4, but 1 divided by 4 is not 0.25. It's 1 over 4. It's a fraction. So basically, these two, no ways. Okay, false all the way. False, false, false. Okay, all right. No, guys, I think you guys get the point. All right, so this was just some examples to sort of like help us to see and identify the different properties. Yes, Trip, I like what you said. Division is not commutative. Okay, division is not commutative at all. At all. Okay. All right. Yeah, also subtraction is not commutative. Very true. Not at all. Okay, guys, here's something else. We say 0 is what we refer to as an identity element. We say 0 is an identity element for addition. Okay. 0 is very special. 0 is referred to as 0 is an identity element for addition. What do we mean by that? What we mean by that is that if you take 0 and you add it to any number, the other number I hate the sound of that track every morning. I hate it. 0 plus 7. 0, we call it an identity element because 7 retains its identity whenever it's added to 0. So the answer is actually 7. Okay, that's why we call 0 an identity element. The other number doesn't change. It stays that way. You know, it's like 0 is that friend for at least for addition. If you came into a friendship and you were someone who does not, let's say, drink or smoke, when you are in the company of someone who is, we could say, would be likened to a 0, that person will basically leave you the same way. There won't be any change or any effect in who you were when you actually came in. So 0 plus 7, the 7 was positive, so it remains positive whenever it is associated with 0. So it's like what Drip says, the other number doesn't change. That's why we call 0 an identity element, but it's only for what? That it's an identity element. It's only for addition that it's an identity element. All right, let's go. Let's look at another number. 1 is an identity element for what? For multiplication. 1 is an identity element for multiplication. All right. What do we mean by that? Let's say 1 times 3, for instance. 1 is multiplied to 3. The 3 was what? Was positive. What's the answer? The answer is 3. So once again, what does the 1 do when we multiply? The 1 does not change the other number. That's why we call 1 an identity element for multiplication. So 0 is an identity element for addition. All right? 0 doesn't change any other number when we add. 1 is an identity element for multiplication, meaning it does not change in the other number when multiplied to that other number. So that's why we call it an identity element. Okay. What about division? Well, obviously, for division, 1 divided by 3. Yes, definitely. Well, okay. So let's be careful with division, right? Remember, 1 divided by 3. All right. This 3 will be 1 over 3, which is actually 0.33. All right. Let's be careful with division. It's only if the other number is the one that starts followed by 1, then it becomes an identity element for division. But if it's 1 that starts and it's followed by the other number, then it's not an identity element. So that's why we are very proud to say that 1 is an identity element for multiplication, whatever the order is, because 1 times 3 will be 3, 3 times 1 will still be equal to 3. So basically 1 does not change the other number, doesn't matter the order. All right, commutative wise doesn't matter, but for division we need to be a bit careful, right? Because if 1 is the one that's starting, then you can see. But if 1 is the one that is following, then that's fine. All right, so let's hold on to the fact that 1 is an identity element for multiplication, whatever the order. 0 is an identity element for addition, whatever the order. So we can trust that. Okay, we can trust that one. Okay, now we can finally enter into the zone of what we wanted to enter into. Oh, just before that, addition and subtraction are inverse operations. Very important property to note, right? Addition and subtraction are inverse operations. All right? Inverse. In other words, they are opposite operations, addition and subtraction. So for instance, if A plus B is equal to C, then it stands to reason that then C minus B is equal to A. Okay. If the addition of these two gives me this, then this C minus this B will give me the A. Alright? Okay. So we say addition and subtraction are inverse operations. Let's just look at an example. 5 plus 3 is equal to 8. Then what? Then 8 minus the 3 will give me the 5. Or we could say 8 minus the 5 will give me the 3. Okay. Yeah. Also, there's this thing of additive inverse. So for instance, I come to you and I say, what is the additive inverse of 7? Okay. What is the additive inverse of 7? Okay. So additive inverse is that number which you add or subtract to get 0. That would be additive inverse. So in your head, you're asking yourself, if they say what is the additive inverse of 7, you're asking yourself the question, what am I going to add or subtract to 7 to get 0? So what is the additive inverse of 7? What's the number that I can add or subtract to 7 to get 0? So the additive inverse of 7 is exactly, it's negative 7. Okay. What is the additive inverse of negative 8? What is the additive inverse of negative 8? So you're asking yourself, what number can I add or subtract to negative 8 to get 0? Because what an additive inverse is that number that you would add or subtract to a particular number to get 0. So an additive inverse is that number which you add or subtract to get 0. Okay, so the additive inverse of negative 8, yes, Lesejo. The additive inverse of negative 8 is, you can just write 8. If you write plus 8, that's also fine. Doesn't really matter. So guys, whether you write plus 8 or you write 8 as a number, remember plus 8 and 8 are basically the same thing. Alright? Okay, I think we've gotten the whole additive inverse. Then there's another thing, multiplicative inverse. What is a multiplicative inverse? It is the number which you multiply with another to get 1. Okay. Multiplicative inverse is simply, it is the number which you multiply with another to get 1. And this comes from the fact that multiplication and division are inverse operations. Okay. Multiplication and division are inverse operations. Okay. So in other words, if A times B is equal to C, then C divided by B is equal to A, and that's something that we know. Multiplication and division are inverse operations. All right. Okay, so hopefully that's clear for us. Multiplication and division are inverse operations. If A times B is equal to C, then C divided by B is equal to A. And hopefully we understand that when we say 5 times 3 is equal to 15, then we know that then it means that 15, which is the answer, divided by 3, for instance, will give us 5. Or we can say 15 divided by 5 will give us 3. Okay, that's why we say multiplication and division are inverse operations. Okay, and if A times B is equal to C, then C divided by B is equal to A. Alright, and this is an example that purely or clearly demonstrates that. Okay, 5 times 3 is equal to 15. 15 divided by 3 is equal to 5, or we can say 15 divided by this 5 is equal to 3. Right? Going back to the multiplicative inverse, so I'm going to ask, what is the multiplicative inverse of 1 over 9? Remember, what did we say multiplicative inverse is? It is the number which you multiply with another to get 1. So what is the multiplicative inverse of 9? Okay, what would we have to multiply 9 with to get 1? What would we have to multiply 9 with to get 1? What is this missing number? Because we want the multiplicative inverse of 9. Ria, no. Tiamo, no. Tabiso, thank you so much. 1 over 9. What would we have to multiply 9 with to get 1? We multiply 9 with 1 over 9 to get 1. Okay. And I'm just going to show you here. Go to your calculator 9 times. What do you have to multiply the 9 with to get 1? 1 over 9. So it's always 1 over the number that has been given to you. So 1 over 9, what do we get? There it is, guys, we get 1. So 9 times 1 over 9 will give us 1. Okay, so what is the multiplicative inverse of 9? It's 1 over 9. What is the, I'm just going to say MI to say multiplicative inverse. Please bear with me. What is the MI? M stands for multiplicative and I stands for inverse. What is the multiplicative inverse of 1 over 7? Let's see if people can get this one. What is the multiplicative inverse of 1 over 7? So in other words, you are asking yourself the question, what do I have to multiply 1 over 7 with to get 1? Okay, I think we are getting on with the game. Yes, it is 7, people. It is 7. Okay, very good. Okay, you guys get the point. So it is 7. Okay, just gonna do 2 more. What is the MI? Remember, MI stands for multiplicative inverse. What is the multiplicative inverse of -3? So the question is, what do I have to multiply -3 by to get 1? Lesejo, you've answered. What does everybody else say? Kay says 3. Audrey says 1 over 3. Different answers. Okay, guys, the answer is negative 1 over 3. Okay, negative 1 over 3. I strategically write that negative in line with the divide sign, because that negative sign obviously means that the entire number is actually itself negative. Okay, grade 9. Grade 10 is to follow after I'm done with this session. So negative times a negative gives us a positive, and then 3 times 1 over 3 gives me the 1. So basically, it's multiplication by negative 1 over 3. That will give me 1. So the multiplicative inverse of negative 3 is negative 1 over 3. Because remember, to get a positive, it's a negative times another negative. That gives me a positive. So hopefully you understand that, guys. Very, very important. Okay, just gonna do one last example. What is the multiplicative inverse of negative 2 over 7? What is the multiplicative? Remember, MI stands for multiplicative inverse. So in other words, what do we need to multiply negative 2 over 7 by to get 1? Negative 2 over 7. What is the multiplicative inverse of negative 2 over 7? Gift says 7. Ria says negative 7. Lesejo says negative 3, 5. Craig says negative 7. Okay. Ria is right if you consider the decimal, but that decimal written as a fraction. Okay, so the answer is negative, because a negative times a negative will give me a positive. This fraction 2 over 7, I'm going to write it as 7 over 2. Okay, do you see that? So the multiplicative inverse, it is negative 7 over 2. This fraction, all I did is I just wrote it inverted. 7 in the numerator, 2 in the denominator, and then basically the sign, because negative times a negative gives me a positive. Ria, it's getting confusing. Okay, let's go back, guys. Remember, what did I say a multiplicative inverse is? I said it is the number which you multiply with another to get what? To get 1. We looked at the first example. What is the multiplicative inverse of 9? Remember 9, guys. 9 is actually 9 over 1. If I was to write it as a fraction, it's 9 over 1. So now we want to find out what the multiplicative inverse of 9 is. Alright? And you guys said it's 1 over 9. What happened? The 9 and the 1? The multiplicative inverse, the 1 is in the numerator, the 9 is in the denominator. Obviously, a positive times a positive will give me a positive. So therefore, that's why we say the answer is 1 over 9. The multiplicative inverse of 9, 9 can be written as 9 over 1, is actually 1 over 9. The opposite, denominator in the numerator, numerator in the denominator. And we don't write negative, but we write positive, because a positive 9 times another positive 1 over 9 will still give me a positive 1. Look at this one. What is the multiplicative inverse of 1 over 7? Multiplicative inverse of 1 over 7, remember we have 1 over 7 times what will give us 1. Okay, this is like saying 7 over 1. We know that 7 over 1 is actually the number 7. Okay, so all we did was we swapped the numerator for the denominator. Since the sign is positive, we still retain the sign of the number that we multiply by as positive, because a positive times a positive gives us a positive. Okay, this one, number 3, what is the multiplicative inverse of negative 3 over 1? All right, negative 3 can be written as negative 3 over 1 times what will give you 1. Now you have a negative sign. Negative times what will give you a positive. So the sign has to be negative. But then 3 over 1 can be written as your multiplicative inverse, numerator for the denominator, denominator for the numerator, negative 1 over 3. So that's the multiplicative inverse is negative 1 over 3. And then this one that I just did now. What is the multiplicative inverse of negative 2 over 7? So I wrote down negative 2 over 7 and I said times what will give us 1. So first and foremost, a negative times what will give me a positive. So that means I need to write another negative. Then I write 2 over 7. Its inverse will be 7 over 2, but it will be negative. So that means the multiplicative inverse of negative 2 over 7 is minus 7 over 2. Okay, let me give you another one. What is the MI of negative 9 over 2? Okay, you guys can do this one. What is the MI of negative 9 over 2? Let's start with that one. What is the multiplicative inverse of negative 9 over 2? Okay, Craig, you've got it down. I think you finally fine. You finally are fine. Okay, and what's beautiful, you can always check your answer after you've written it down, right? Your calculator is nearby, you can always check it. So for instance, Ria, okay, let's check this. You said negative 9 over 2, that was the question, times what will give you 1. So if you take your calculator and you say negative, and you say 9 over 2, then you take what you've written. You said times, Ria said negative 2, so it means times negative 2. Do you get 1? No, your calculator gives you 9, so that means no, we have to re-look at what we've just done. Okay, let's go and take the value that Craig gave us. So you said negative 9 over 2 times what? Times negative 2 over 9. Let's look at what the answer. We get 1. Okay, so that clearly means that what is the multiplicative inverse of negative 9 over 2? It is negative 2 over 9. That is it. Okay, all right. So please, guys, this beautiful calculator. Yes. You just swap and then look at the sign. If the sign is negative, it means the sign of the other one will be negative. I'm sure you saw as well. If the sign is positive, it means the sign of the other one will also be positive. So I think in summary, that's what you do. You basically just swap the numerator and the denominator, and then you do what? You just write the same sign as you had for the other number. But that only applies for multiplicative inverse. Okay, guys, last one. What is the multiplicative inverse of 12? Tomorrow at 7 a.m. Audrey. Very good, Ria. 12 can be written as 12 over 1. So times what? 1 over 12. You are spot on. Okay, so 12 can be written as 12 over 1. as a fraction times what will give us 1? It's 1 over 12. So the multiplicative inverse is 1 over 12. Very good. Okay. Okay. In conclusion, I just want to cover these two things: factors and multiples. Grade 9. So we're going to go into grade 10 shortly. Factors and multiples. What are factors? Factors of a number are those numbers that divide exactly into a whole number without leaving a remainder. It's like numbers that fit in to another number without leaving a remainder. Okay. So, e.g., the factors of 12. Okay. I want someone to tell me what the factors of 12 are. You can list them in the comment section. What are the factors of 12? I want all of them, not some of them. Craig, you are very fast. You are very fast. The question is, did you list all of them? That's the question. Okay, so I see your guys' numbers, but let's check this out. Okay, so the first number that goes into 12, the smallest number that goes into 12 is what? Is 1. Very important. Okay, we always check 1. 1 goes into 12 how many times? 12 times. That is going to be our end number. So how many times does 1 go into 12? 1 goes into 12 times. So we write that number as well. That's the pair of numbers. When multiplied together, that give us 12. Let's look at this. The next number. After 1, does 2 go into 12? Yes. 2 goes into 12 how many times? 6 times. So that's the other pair. 2 times 6 gives us 12. After 2, we have 3. Does 3 go into 12? Yes, 3 does go into 12. How many times? 4 times. After 3, we have 4. 4 is already there. 5. Does 5 go into 12? No. So basically, these are our factors. The factors of 12 are 1, 2, 3, 4, 6, and 12. Very important. Alright, so you guys understand the whole concept of factors. Numbers that fit into other numbers without leaving a remainder. Please, people, whenever you are asked to list factors, you need to list all of the factors. You can't miss one. If you miss one, it means you have not listed all the factors. Alright, so I hope we are clear there. What are multiples? Multiples of a number are numbers obtained if the number is multiplied by natural numbers. So multiples of a number are numbers obtained if the number is multiplied by natural numbers. Okay. So example. Multiples of 3. So if I was to say what are the multiples of 3, what are the multiples of 3? So if you take this number and you start multiplying it by natural numbers, Natural numbers are numbers that start at 1, increase by 1 all the way to infinity. So the first multiple of 3 will obviously be, what's 3 times 1? 3. What's 3 times 2? 6. What's 3 times 3? 9. What's 3 times 4? 12. What's 3 times 5? 15. And I'm sure it goes on and on and on. We cannot ever, obviously, because we know natural numbers all the way to infinity, so we cannot list all of them. But oftentimes when they ask us to list multiples, they'll give us a range. They'll be like, list the multiples between maybe 1 and 15. Or they'll say, list the multiples between 20 and 30. Then you have to list only those multiples between 20 and 30 for 3. For instance, if they said list the multiples of 3 between 20 and 30, then you would list those multiples of 3 between 20 and 30. And what would those multiples be? If they said the multiples of 3 between 20 and 30, all right, the multiples of 3 between 20 and 30 would be 21, 24, 27, all right? Those would be the multiples of 3 between 20 and 30. Now remember, I said between, all right? So in between does not include 30, unless they had said list all the multiples from 20 to 30. Then basically you would list 21, 24, 27, you would include as well as 30. But they say between. You know, if something is in between, it does not include what's at the end. It does not include what is at the beginning. It's just between, right? And obviously, questions vary. They change according to what questions they want to ask. I think, guys, we will hold it right here. Okay. Right. So today, what did we do? Today, we looked at properties of whole numbers. We looked at what we call the commutative property of addition and multiplication. A plus B is equal to B plus A. It's the same thing as 1 plus 2 is equal to 2 plus 1. This is the commutative property of addition. We looked at the commutative property of multiplication. 2 times 1 is equal to 1 times 2. Doesn't matter the order that you place numbers for addition and multiplication, you still get the same answer. That's the commutative property of addition and multiplication. Then we looked at the associative property. When you add or multiply 3 or more rational numbers, you get the same sum or product no matter how you group or associate the numbers. Then we looked at some examples. Then we looked at the distributive property. We looked at some quick game challenges to kind of identify if the statements are true and which property was used. This is grade 9. Then we looked at some examples. We looked at how addition and subtraction are inverse operations. All right. We looked at the additive inverse. Okay. We looked at the multiplicative inverse. We looked at how multiplication and division are inverse operations. We did some additive inverse and multiplicative inverse questions. And then we ended off by defining what factors and multiples are. We have not really gotten or gone into the revision of other things related to factors. So we're going to hold it right here. Grade 9s, thank you so much. That was a good session. I will now end this session and then come back on for the grade 10s. All right. Thank you so much to those that joined in. I will be posting the homework questions. I believe also the grade 9 group for WhatsApp has also been started. So I'll actually also be making sure that I send the picture for the homework there as well. But I'll also be uploading the video slide pictures for the homework, what you guys need to do, so that we can apply the concepts that you've learned today, and then we'll pick it up tomorrow, same time, 7 a.m. for the grade 9s. Please, people, tomorrow, same time, grade 9s will continue with this session and continue with the rest of the content. Okay, those who have joined in for the first time, welcome. Please do follow the host And please do go ahead, go and subscribe to my YouTube channel. It's called Maths is a Game. You can actually go onto my bio. The YouTube icon is there. You can click on it. It will send you to the YouTube channel. All the videos of all the lessons and the sessions that I've done ever since we started the term 1 program early in December are already on there. You can go and review them. Grade 9 and grade 10 was done together at the beginning because much of the content at the beginning is the same. And then now we started to branch off this week. So the grade 9s will be meeting every morning at 7 a.m. You guys can join in the session at 7 a.m. But all the sessions will be uploaded onto the YouTube channel. You can watch the sessions there if you have missed anything. And then the homework questions will be posted on the page. I'll post those a little bit later on after I'm done with the grade 10 session. But thank you so much. You guys have been great sports, and thank you for answering the questions in the comment section. Thank you for everything. You guys have been phenomenal. You've been great sports. We'll close this session, grade 9, and then grade 10. I'm just going to leave the live because I need this video saved so that it is separate and apart from the grade 10 session. Grade 10s, I'm coming back just now.